All right, I'm going to do two more evaluations just to get us kind of transitioned over to our next topic. So I want to evaluate first log base 2 of negative 4. And I'm going to try to do this the same way I did before. I'm going to set this equal to y. So I'll have 2 to the y is equal to negative 4. And now I'm trying to think of a way to rewrite negative 4 as 2 to something. I'm trying to get the same base on both sides here, but I'm having trouble with this. And if I think about this, 2 to the y equals negative 4. If I think about my exponential functions from the previous section, if I had 2 to the y, well, that exponential function 2 to the y, it's never equal to any negative number. It never goes below the x-axis there. So this is never going to happen here, which means log base 2 of negative 4 is undefined. And so if we wanted to write down a final answer there for that evaluation, we would say it's undefined. Let's do one more. Let's say evaluate. Let's do log base, we can stick to 2 of 0. I'll do it the same way. I'll set it equal to y, so 2 to the y is equal to 0. And again, if you look at our graph of our exponential here, we have that asymptote at 0, but it never crosses it. It never gets to 0. So this is another one that's going to give us undefined here. So moral of the story on this stuff is that you cannot plug in a negative or a 0 into a logarithm. It just never makes any sense. You know, in the two examples we just did, the numbers weren't super important there, but what was important was the negative 4 was negative and the 0 was 0. So in the previous video, we had plugged in a bunch of positive numbers. Those all worked out, you know, or at least they gave us a shot. But negative numbers are 0. We cannot plug those into a logarithmic function. Now, the reason I put those in their separate video is the next concept we want to look at is the concept of domain. And so I'll just write down what I just said. The domain of log base a of x is 0 to infinity. So I cannot plug in 0. I cannot plug in negative numbers. It's very similar to square roots, except square roots you could plug in 0, so that was a bracket. And let's do some examples with the domain of a logarithm. So let's say example, find the domain. And let's see here. So if we want to find the domain, let's go ahead and do a few of these. Let's say part A. Let's say log base 3 of x minus 5. Well, from above, we know that we can only plug in positive numbers into a logarithm. In this case, what we're plugging into the logarithm is x minus 5. So that has to be positive. So I can add 5 to both sides. I get x is greater than 5, and then however MyLab wants you to write the answers, maybe in interval notation, maybe in set notation, whatever it wants there, keep it happy. And we'll put an OR here. And so let's see here. So again, just to recap, they're very similar to square roots. For logarithms, though, it has to be strictly greater than 0. Yeah, let's see here. Let's say part B. Let's do, one of my favorites from the square roots, you probably remember. Let's see log base 4 of negative x. So again, domain of a logarithm, we're allowed to plug in positive numbers, so we have to set this greater than 0. Whatever's inside the logarithm, set it greater than 0. That time now, because with this negative, we flip the sign, we end up getting x is less than 0. So negative infinity to 0. Or x such that x is less than 0. And let's see here, let's say say part C. Let's do log, whatever, base 5 of x squared. So on the inside of the logarithm, we have an x squared, and you know, I should point out too that the base doesn't matter. In any logarithm you have, you can't plug in negative numbers, you can't plug in 0. So here we're plugging in x squared. X squared is greater than 0. That's a polynomial inequality. We use the number lines for those. If we plug in something to the left of 0, we get a positive. If we plug in something to the right of 0, we get a positive. And we're looking for positives here. We want positive numbers in these logarithms. So in this case, it would be negative infinity to 0, union 0 to infinity. The only place you get 0 is 0, so I did not include that. And then you don't get any negative numbers from x squared, so everything else is fine. And let's see, let's do another one here. Let's say log base 6 of x squared minus 4x minus 5. So I know for a fact for log domains, I need this inside part to be greater than 0. To solve an inequality like that, I'm going to go ahead and set it equal to 0. I'll factor it at the same time as well. So x minus 5, x plus 1. So on my number line, I need a negative 1 and I need a positive 5. If I fill out this number line, I'll go ahead and just fill it out for us. And you know how to do the inequalities now from our previous chapter. But here, if you plug in numbers, you're going to have a positive to the left of negative 1, a negative in between, and a positive to the right of 5. So let's see here, we wanted the greater thans here. So this domain is going to be negative infinity to negative 1, union 5 to infinity. And if you need a refresh on those inequalities, you know, feel free to come and get help. And let's see here, part E, let's do one more here. Let's say log base 7 of x plus 5 divided by x minus 2. So whatever's inside the logarithm has to be greater than 0. Can't be equal to 0, can't be less than 0. In this case, we have a rational inequality, and we know we need our intercept on there, negative 5, and our asymptote at 2. I'll go ahead and fill in this one as well. It coincidentally happens to be the same as the previous one, plus minus plus. And we want the positives here. And let's see here. So one thing to keep in mind, we don't want equal to 0, so nothing's going to have a bracket on it here. The asymptote wouldn't have a bracket regardless, but neither is the intercept here because we do not want 0 as part of our domain. You know, part of what's being plugged into that logarithm.